Hello friends and welcome. Today we shall talk about cheese and paneer. Here is what we are going to discuss in today's deliberation. First, we shall try to get a general idea about what cheese is, followed by its classification. Then we shall talk about its processing and the factors influencing its spoilage. And lastly, we shall try to briefly highlight what paneer is. To begin with, let me first of all give you a brief idea about cheese. Cheese is a solid food made from the milk of cows, goats, sheep and other mammals. Cheese is made by coagulating milk. This is accomplished by first acidification with the bacterial culture and then employing an enzyme rennet or rennet substitutes to coagulate the milk to curds and whey. The precise bacteria and processing of the curd play a role in defining the texture and flavor of most cheeses. There are hundreds of types of cheese produced all over the world. Different styles and flavors of cheese are the result of using milk from various mammals or with different butterfat contents, employing particular species of bacteria and molds, and varying the length of aging and other processing treatments. Other factors include animal diet and the addition of flavoring agents such as herbs, spices or wood smoke. Whether the milk is pasteurized may also affect the flavor. Cheeses are eaten both on their own and cooked as a part of various dishes. Most cheeses melt when heated. Cheese has served as a hedge against famine and as a good travel food. It is valuable for its portability, long life and high content of fat, protein, calcium and phosphorus. Cheese is a more compact form of nutrition and has a longer shelf life than the milk from which it is made. Proposed dates for the origin of cheese making range from around 8000 BC to 3000 BC. The first cheese may have been made by people in the Middle East or by nomadic Turkic tribes in Central Asia. Codex Alimentarius FAO WHO Standard No. 6 defines cheese as fresh or ripened solid or semi-solid product in which the whey protein-casein ratio does not exceed that of milk obtained by coagulating wholly or partly milk, skimmed milk, partly skimmed milk, cream, whey cream or buttermilk through the action of rennet or other suitable coagulating agents and by partially draining the whey resulting from such coagulation, or by pressing techniques involving coagulation of milk and or materials obtained from milk which give an end product which has similar physical, chemical and organoleptic characteristics as the products systemized under classification of cheese. Worldwide, cheese is a major agricultural product. According to FAO United Nations 2011, over 20 million metric tons of cheese are produced worldwide. Now let's move on to the classification of cheese. Some cheeses are categorized by the source of the milk used to produce them, while most of the world's commercially available cheese is made from cow's milk. Many parts of the world also produce cheese from goats, buffaloes and sheep. For cheeses not produced from cow milk, indication of the species is mandatory. Now, classification on the basis of fat content. On the basis of fat content, cheeses are classified as high fat contains more than 60% fat. Examples are Robiola, Telaggio, etc. Full fat contains 45 to 60% fat. Examples are Montasio, Rachera, Cheddar, etc. Medium fat contains 25 to 45% fat. Examples are Parmesan, Grana, etc. Low fat contains 10 to 25% fat. Example is Emmental. Skimmed milk cheese contains 10% or less than 10% fat. Now, classification on the basis of moisture content. The moisture content controls the cheese hardness, and on that basis, cheeses are classified as fresh cheese, soft cheese, semi-hard cheese, hard cheese, very hard cheese. Now, classification on the basis of curing characteristics. Cheeses are classified as bacterial cured or ripened cheese, which includes surface ripened and interior ripened cheese, mold cured or ripened cheese. There are three main categories of cheese in which the presence of mold is a significant feature. These are soft ripened cheeses, wash-rinsed cheeses, and blue cheeses. Uncured or unripened cheeses. Unripened cheeses are not aged using different bacterial cultures. They are used immediately after processing. Examples are mozzarella cheese and cottage cheese. Now, classification on the basis of duration of ripening. Most of the cheeses are ripened under controlled temperature and humidity. However, each of the type has its distinguished duration of ripening, and on that basis, cheeses are classified as fresh cheese, short ripened cheese, medium ripened cheese, and long ripened cheeses. Now, on the basis of denomination, cheeses are classified as protected denomination of origin cheeses, cheeses with protected geographical indication, guaranteed traditional specialty cheeses. Now, classification on the basis of processing technology. On the basis of processing technology and the temperature at which the curd is cooked, cheeses are classified as raw cheese, semi-cooked cheese, cooked cheese, pasta fileta cheese, molded cheese, or blue cheese. Now we'll look at the cheese production. Though there are numerous cheese varieties, the manufacturing processes of most of them share several common steps. Variations at one or more steps during manufacture produce cheeses of different textures and flavors. The essential steps in cheese making are milk pretreatment. Milk used for cheese making is normally standardized and heat treated. In some cases, milk is homogenized. The standardization of milk has become necessary to ensure that milk obtained from several producers or dairies is of a standard composition and condition throughout the year. This is critical in cheese making because the legal standards of various cheeses specify certain fat to protein ratios. It is also common to add color, annatto or carotene, and calcium in the form of calcium chloride to the milk and to adjust milk to a desired level known as pre-acidification. Pasteurization is the most commonly used heat treatment, 72 degrees Celsius with 15 seconds holding time. It not only destroys most of the bacteria present, including lactic acid bacteria, but also inactivates many enzymes. However, many cheeses are still produced from raw milk, especially in Europe. Coagulation. Coagulation is the step during which the milk undergoes a profound physical and rheological change, that is, gelation. Milk gel is formed by aggregation of milk protein, the caseins. This can be accomplished by the action of a proteolytic enzyme, lowering the pH below the isoelectric point of protein, heating to about 90 degrees Celsius at a pH of about 5.2, that is higher than the isoelectric point. Among these, enzymatic coagulation is the most popular. Acid coagulation via food-grade acidulants is used to manufacture quark, cottage and cream cheeses. Enzymatic coagulation is accomplished by enzymes from animal, plant or microbial origin. Enzymatic coagulation consists of two phases. During the first or primary phase, the hydrophilic hairy structure stabilized by steric hindrance of kappa casein is cleaved off at phenylalanine 105 methionine 106 bond. The secondary or clotting phase is initiated as 85 to 90% of the kappa casein is cleaved and results in aggregation of the altered protein micelles. Next step in the cheese making process is syneresis. Due to its porous nature, the coagulum has the propensity to contract and expel entrapped liquid. This is known as syneresis, an important step in concentrating the milk. To a great extent, the success of the remaining cheese making steps depends on satisfactorily draining the whey. In an undisturbed gel, however, syneresis occurs very slowly. Therefore, during cheese making, syneresis is accelerated by cutting the coagulum into small cubes, which increases the surface area and reduces the distance for the diffusion process to facilitate whey removal. Syneresis can also be enhanced by decreasing the pH or increasing the temperature of the coagulum. Stirring exerts pressure, causing curd particles to collide and facilitates their compression for a short time. Stirring also keeps the curd from settling in the vat. Cooking the curd, also known as scalding, enhances syneresis by facilitating contraction of the protein matrix. Heating further enhances acid production by the starter organisms. Lowering pH combined with increased temperature not only helps to expel more whey but also affects the dissolution of calcium phosphate and thus has major implication for characteristics of the cheese. Another step involved in cheese making is shaping and salting. When the curd is at the desired moisture content and pH, it is separated from the whey. The curd particles are subsequently shaped into some form and salted, primarily by sodium chloride, not necessarily in that order. These steps, though common for most cheeses, are performed very differently depending on the cheese type. The manner in which cheese curd and whey are separated can affect texture as well as color and flavor. Salt is sprinkled on at a level of about 2 to 3%, which expels additional whey. The salted curd is then hooped in molds and pressed overnight. Brine salting is a slow process, taking several days for uniform salt distribution within a cheese block. Regardless of the method used, salting is a vital step in cheese making because unsalted cheese is virtually tasteless. Salt also plays a major role in the texture, flavor, and microbial quality of cheese. It inhibits the growth of certain bacteria which are harmful to the cheese and cause spoilage, especially on the surface. It further assists in dissolving the casein and in the rind formation, as well as in slowing down enzyme activity. Another step involved in cheese making is ripening. Ripening is the natural process of microbial and biochemical reactions that occur in a cheese after its manufacture and during storage. Ripening gives different cheeses their unique flavors, textures, and appearances. Except for some soft cheeses, examples are cottage cheese, cream cheese, quark cheese. Almost all cheeses are held under controlled conditions to develop the distinct attributes. Moving on, let's shift our focus to the factors influencing cheese ripening. The primary factors in this process are storage temperature and humidity. However, humidity plays less important role in hermetically packed cheeses, example with a wax coating. Fat content, level of amino acids, fatty acids and other byproducts of enzymatic action and also the residual microflora of curd also play an important role in cheese ripening. Now, let us discuss microbial spoilage of cheese and its prevention. Microbiological spoilage of cheese is one of the important reasons that render the nutritious and tasty cheese not only inedible but also a potential source of infection. The spoilage may be due to bacteria or fungi. Now, fungal spoilage. Although mould varieties are essential for ripening of certain cheese varieties like Roquefort cheese, growth of other molds is strictly undesirable. Mould spoilage makes the cheese unpleasant in appearance, conferring it with a musty taint or odor and liquefaction of the cheese. Modified atmosphere packaging may be adopted in pre-packed cheese varieties, but There are incidences of growth of molds in the residual air pockets due to improper packaging or puncture. In countries where there is legal sanction, natamycin or sorbic acid may be incorporated into the packaging to prevent cheese spoilage. Now, spoilage due to yeasts. Yeasts too cause spoilage of cheeses during storage. The defects produced are gassiness or flavors and odors. Yeasts are also capable of proliferating on the surface of ripened cheeses, more so if the surface becomes wet, causing slime formation. Now, bacterial spoilage. Bacterial spoilage may occur in fresh cheeses having a sufficiently high pH, such as cottage cheese. The causative organisms are gram-negative psychotrophic species. These cause bitterness, putrefaction and rancid odor and liquefaction, gelatinization of curd, slime and mucus formation on cheese surfaces. Bacteria may also cause spoilage by producing gas internally in the cheese, resulting in the formation of slits, small holes or blown packs. Dear friends, let's now talk about paneer. Paneer is a popular traditional heat and acid coagulated fresh cheese. It is mainly used as a base material for the preparation of large number of culinary South Asian cuisines. Paneer is highly nutritious and wholesome food as it contains milk fat, protein, minerals, vitamins and other minor nutrients of milk. According to PFA 1983, paneer has been defined as a product obtained from cow or buffalo milk or combinations thereof by precipitation with sour milk, lactic acid or citric acid. It shall not contain more than 70% moisture and milk fat content shall not be less than 50% of the dry matter. The milk fat content of skim milk paneer shall not exceed 13% of dry matter. Typically, it is a marble to light creamy white in appearance. It must have firm and cohesive body with slight sponginess. The texture should be more compact, smooth and velvety. The flavor should be pleasingly mild acidic, slight sweet and nutty. As per the Bureau of Indian Standards, the total plate count should not exceed 5 by 10 raised to the power 5. Coliform count not more than 90 and yeast and mold count not more than 250 colony forming units per gram. The chemical and physical change in the casein and whey proteins brought about by the combined action of heat and acid treatments form the basis of paneer making. On acidification, the micelles become unstable and aggregate as a result of charge neutralization, leading to the formation of chains and clusters that are linked together to give a three-dimensional network. In milks preheated at higher temperatures, gelation occurs more rapidly at a higher pH than in unheated milk. Interaction of whey proteins with casein micelles on heating milk at its natural pH may increase the hydrophobicity of the micellar surface and reduce the hydration barrier against aggregation, thus allowing aggregation and gelation to occur at a higher pH than in unheated milk. Heating milk also results in dissociation of kappa casein from micelles, and this could further sensitize the alpha S casein framework to calcium-induced aggregation. The development of typical rheological characteristics of paneer could be due to the intensive heat-induced protein-protein interactions. Paneer manufacture essentially involves the formation co-precipitates due to complexion of whey proteins denatured by the heat and the casein. Serum proteins, particularly alpha-lactoglobulin, are bonded to alpha-casein via disulfide bridges and calcium linkates. The higher the degree of co-precipitation, the greater will be the total solid recovery and the yield of paneer. With this, we conclude today's lecture and I hope you have understood it well. Thank you and goodbye.
you.